Hi, here we have another question from Iran Mathematical Olympiad round number 1, year 1997. The question says, A, B, and C are element of real number. A and 4A plus 3B plus 2C, they have the same sign. The question is, can the polynomial ax2 plus bx plus c equal to 0 have two real roots in the interval between 1 and 2? In the exam, the question was actually a multiple choice exercise. So these are the options. If two roots exist, they cannot be in the interval between 1 and 4. If two roots exist, they cannot be in the interval between 1 and 2. The equation has two real roots. The two roots of the equation, if they exist, have different signs, and the two roots of the equation, if they exist, have the same sign. Usually, the first round of Iranian Mathematical Olympiad consists of multiple choice questions. You get 30 questions for 3 hours, so each question 6 minutes. This question was among the more difficult one, so maybe I spend 10 minutes, try to solve this exercise, and after that, come back and see the solution. All right, let's look at the solution. This is the polynomial we have, ax2 plus bx plus c equal to 0. So assuming that x1 and x2 are the roots of this polynomial, we can write this polynomial as a multiply x minus x1 times x minus x2. Now let's expand this. So if you expand this, it will be ax2, and this one will be minus a x1 plus x2 times x, and the last part will be plus a x1 times x2. Now obviously, if these two are going to be equal, it means that b has to be equal to minus a times x1 plus x2, and c has to be equal a times x1 multiply x2. All right, so now we have this understanding. We can actually calculate this term 4a plus 3b plus 2c. This will be 4a, and for 3b, we can write its equivalent, minus 3a times x1 plus x2. And for c, we can write a x1 x2, so it will be 2a x1 x2. And obviously, we can factor a from here, so it will be 4 minus 3 times x1 plus x2 plus 2 x1 x2. In the original exercise, we say that a and 4a plus 3b plus 2c, they have the same sign. It means that a and a multiply this term must have the same sign. So a and a, obviously, they have the same sign. So this term must be a positive number. Okay, so we have shown that based on the property given in the exercise, this term 4 minus 3 times x1 plus x2 plus 2 x1 x2 has to be a positive number. We can rewrite this in the following format. So instead of 4, I write 2 plus 2. Instead of this, I write minus 2x1 minus x2 and minus x1 minus 2x2. So this will be minus 3x1 plus x2. And this one, I put it x1, x2. Here again, x1, x2. Now, actually, each of these parts, so this part and this part can be decomposed. This one will be x1 minus 1 times x2 minus 2. And this one will be x2 minus 1 times x1 minus 2. And we know that this has to be larger than 0. Okay, let's assume that we have two roots, x1 and x2, that is in this interval between 1 and 2. So obviously that means this term will be a positive value, this term will be a negative value. So this whole multiplication will be a negative value. Same for this one. This one is a positive, this one is negative, so this one is also a negative value. That means this side of the inequality, this has to be a negative number. So it cannot be larger than 0. Therefore, if we have two roots between 1 and 2, it's not possible to have this property. So if we look at the answers, we see that option B, it says if two roots exist, they cannot be in the interval between 1 and 2. And that is the correct answer. In multiple choice exercises, we can sometimes eliminate the other options, the wrong option, and then based on that, find the correct answer. So let's see if we can eliminate all the other options. For example, it says if two roots exist, they cannot be in the interval between 1 and 4. In this case, we can try to create a polynomial that fulfills the properties given in the exercise. But let's say the roots are already in this interval. For example, if we take this polynomial x minus 3 times x minus 2, we can expand it. It becomes x2 minus 5x plus 6. So obviously a is 1, so the sign is positive. And then if we calculate 4a plus 3b plus 2c, this is 4 minus 15 plus 12. So this becomes 16. So minus 15 is 1. So the sign of this is positive. the sign of a is also positive. So this is a polynomial that fulfills the property given in the exercise. But as you can see, we have two roots that they are between 1 and 4, and they have the same sign. So basically, by giving this example, we can easily eliminate option A because it says they cannot exist between 1 and 4, and option D, the two roots of the equation, if they exist, have different signs. But these are, we gave already a wrong example. For example, option C, the equation has two real roots. We can just give this very simple counter example, x2 plus 1. So a is 1, and 4a plus 3b plus 2c is equal to 6. So both of them have positive sign, and the roots are not real. So this option can also be easily eliminated. And the last option, it says if the two roots exist, they must have the same sign. Again, we can give another counter example, x plus 4 times x minus 1. It becomes x2 plus 3x minus 4. A, the sign of A is positive, and if we calculate 4a plus 3b plus 2c, this one is equal to 5. So also this one is positive, so it fulfills the properties of the exercise. But we can see that we have two roots that the signs are not equal. So this one can also be eliminated. And based on this, we could guess that option B is the correct answer. All right, let's see what we have learned in this exercise. If you have a polynomial in the format of an x power n plus a n minus 1 x power n minus 1 plus a1 x plus a0, we can rewrite this in this format: an multiply x minus x1 multiply x minus x2 till x minus xn, and these are the roots of these polynomial. What we know is that the summation of all roots is equal to minus 1 power 1 times an minus 1 divided by an. This is the summation of all roots. If we sum xi multiply xj, I should not be equal j, over all I and j, this one would be equal to minus 1 power 2 an minus 2 divided by an. And the same for the other multiplication. Eventually, the last one is multiplication of all roots will be equal to minus 1 power n times a0 divided by an. For example, here I have an example, x3 minus 6x2 plus 11x minus 6. This one can be decomposed in this format, so the roots are 1, 2, and 3. And you can see that if you add all the roots together, the sum will be 6. And if we take this an minus 1, so minus 6, we multiply it to a minus, so it's 6 divided by 1 is 6. So the summation of all roots is equal to 6. And if we take the multiplication of roots 2 by 2, so 1 times 2, 2, 1 times 3, 3, so totally 5. 2 times 3, 6 is 11 totally. So it's basically 11 divided by 1. And if we multiply all of them together, it's 6. And this is minus times minus 6 divided by 1 is 6. Based on these rules that we have, sometimes we can solve certain type of exercises that the summation of roots is equal minus 1 an minus 1 divided by an, or multiplication of all roots is equal a0 times minus 1 power n divided by an. All right, so that's end of the video. I hope that you learned something new. See you next time. Bye.